Hello and welcome to Permutations and Combinations Day 2. We are in the probability packet and we've turned the page to page 4 if you want to follow along in your notes. And we're going to talk combinations today. To reiterate, yesterday a lot of the situations you looked at were situations where you're trying to come up with number of arrangements of items where order matters. That's a permutation. Combinations is going to change that a little bit, but we'll take a look in a second. We got to start the day with the joke, so here it is. It's an English grammar joke. Did you hear about the semicolon that broke the grammar law? Okay. He was given 2 consecutive sentences, semicolon, middle of 2 sentences. That's the joke. All right. Can you pause the video and after you've read the warm-up, can you pause the video and give it a try for yourself? You're looking at 1 and 2, pause, and then come back, and we'll see how we compare with some strategies here. Warm-up number 1, you have 5 students in your class: Addison, Billy, Courtney, Don, and Emma. You can just pretend like Don is John. I was trying to come up with 5 members of our class, but we didn't have anyone who started with a D, so I turned John into Don. It says, how many different groups of 2 students can I choose for the class council if the first one I pick is the pres and the second one's the vice president? You ask yourself, a lot of times today we're going to ask, does order matter? And if you're choosing the president first, order definitely matters, right? Because me picking Addison and Billy is a different arrangement than me picking Billy first and then Addison. I'm thinking of Billy Madison, the movie. So Billy, then Addison, because Billy would be president in the second way. So when there are designated positions, you can do it in one of 2 ways. We can use blanks and put the first blank for the pres and the second blank for your choices for vice president. You have 5 choices for the president, and then you've picked somebody, they're gone. You have 4 left over to be the vice, so there's 20 ways. That's a permutation. That's the same thing as saying 5 people. You want the permutations of picking 2. For the second one, we don't have a method yet. It says, how many groups of 2 students can I pick if they're both just going to simply be council members? So the order doesn't really matter. Me picking Addison and Billy is the exact same thing as me picking Billy first and then Addison, because they're both on this council and they don't have different positions. So if I'm blanking, maybe I can list out the other possibilities. I don't think there's too many here. It could be Addison and Billy, it could be Addison and Courtney, Addison and this mystery Don person, Addison and Emma. That's 4 ways. Reversing the order is going to give you the same council, so there's no more ways than that. Those are the Addison ways. What about Billy and Courtney? Billy and Don. I can't wait to meet him. Billy and Emma, right? 3 more ways. How about Courtney and Don? Courtney and Emma is a choice. And then I think the only one I'm missing is Don and Emma. And now we've accounted for all the, if you count them up, 10 ways that you can pick 2 people out of 5 if order doesn't matter. And there must be a quicker way than this, because if we were talking all the members of our class, all 27 of you, that would take so long to list out. So a combination comes to mind. A combination is a selection in which order does not matter. Doesn't not matter. So it's a little bit different from permutations that we talked about yesterday. Still an arrangement of items, but the order doesn't matter here. When all items are different, the number of combinations of R items selected from N available, so kind of like NPR from yesterday, but NCR today for combinations, still going to be a fraction. It's going to look almost the same. N factorial remains up top, the total that you're picking from. On the bottom, just like with permutations, the difference between the 2, so n minus r factorial goes here, but there's fewer combinations, and we'll talk about the theories about why. So on the bottom, there's also an r factorial, just an extra part to that denominator. And we're going to try an example. Let's say I had 5 class members, and I don't want to pick 2 for my council. I want to pick 3 for my class council. So ways that you can pick 3 people out of 5 if order doesn't matter. And the formula says 5 factorial up top, and then 5 minus 3 factorial, so 2 factorial times r factorial, so times 3 factorial. Let's try this one without a calculator. So you have 5, 4, 3, 2, 1. I'll just leave off the 1. On the bottom, 2 factorial is just a 2, and then 3 factorial should be 3 times 2, making part of this cancel, and it'd be a little easier to simplify. So 20 over 2 gives you 10 ways. You can pick 3 people out of 5. Now, before we leave this example, is this kind of curious? In number 2, we were picking 2 out of 5. This was 2C5, and you got 10. Why is that the same thing as, oh, I wrote that wrong, sorry. This would be 5C2, right? You have 5 items and you're picking 2 of them. So my question is, why is 5C2 the same as 5C3? Does that make any sense? I guess if you think about it, it does. Me picking 2 of the 5 is the same thing as number of ways for me to leave out the other 3 people, right? So if 3 and 2 add up to 5, expect yourself to see some repeats with these combinations that we get in some of these answers. Let's try the examples. Now this is going to be kind of fun. Each situation we look at, you make an opinion for yourself as to whether you decide order is going to matter or not. For some of them, there's only one right way to do it. Order is either going to matter or it doesn't. There's going to be at least one where you can make a case for either, and that is the beauty of these conversations, right? Sometimes there's more than one way to look at a situation. 3 is a 2-part question. It says you have a committee, and there's a couple stipulations. You have to have 3 faculty members and 2 students. So I'm going to write 2 different combinations, kind of like the blanks method for counting, one for the faculty, one for the students. We have 6 faculty members to choose from, and we want to pick 3 of them. Now notice, I just went straight to a combination instead of a permutation. I went through that kind of quickly, but I should note that the order doesn't really matter. If you see that it's just a random committee where there's no designated positions for the people, the order in which I pick those 3 faculty members shouldn't be that influential. So this is for the faculty. Then I have the students. Whoa, that's very sloppy. Okay, so and I'm picking students. Think back to counting principles where you multiply your blank for your ways you can arrange the faculty. Now we have a blank for a ways we can arrange the students. And see if you can come up with it. What C what, right? Think of how many you're picking from. You're picking from 10, and you want to choose 2 of those people. Woof. Okay, sorry, did not mean to bark like a dog. There should be a way to do this in the calculator, and you probably noticed it when you were doing NPRs from yesterday. So I want to try this with an NCR. It was in the same exact menu. Let's try 6C3 instead of using the formula. So a 6, then math, probability, same exact menu. And then do you see it right under number 2 that we were using yesterday? Number 3 says NCR. So we can do 6C3. And if you want, just put times, and we can type the next one. Actually, I think I have to, on this type of calculator, maybe hit the right arrow so my cursor goes big. And I'll multiply that by 6 again, right? And I'll go to math, probability, NCR. This is a combination, and then 2. And I already see my mistake. It was supposed to be 10C2, right? So I'll fix that, go over and fix it. How about 6C3 times 10C2? Enter to get 900. Looks okay. We'll say 900. Whoops. So 900 ways you could do that. Let's look at number 4. This is a nice thought. I'm going to divide you guys into 8 groups, and then what could be cooler? We're going to write a poem about math. That just sounds so nice and relaxing and fun. Each group of 8 is going to submit 1 poem for the group, and I'm going to select 4 poems just to put up on the bulletin board in the back of the room. Ask yourself, are you using a permutation or a combination? Does order matter or not? If they're all going up on the bulletin board anyway, it doesn't really matter which one I pick first, second, third, or fourth. Let's go with a combination for this one. You have 8 groups to choose from, 8 different poems, and you're picking 4 to put up on the bulletin board. So one more time, I'll go back, do the steps here, and we've got 8C4. The 8 goes first, math, probability, and number 3. NCR, and I want to choose 4, and I get 70 ways. That's a lot of ways I could pick, but I'm sure all of your poems will just be so great and unique in their own ways, right? Who am I to pick? Now I slightly altered the competition. Now I'm just, well, you still get your poem up on the wall, but the way I pick them is going to make them arranged from left to right on the wall. I was trying to write you guys a situation where here, let me underline it, order is going to matter, right? Because if I pick the first four poems are my winners, where they go up on the wall is going to change based on the order in which I pick them. So I wanted this to go right after it with an 8P4, because now me picking them creates a new outcome. The arrangement of the poems on the wall, right? If you're talking about order from left to right, will be a little bit different. So for this one, it's an 8P4. And you get a bigger number. Once I type this into the calculator, you get 1,680 ways I could do that. I just want to pause and look at the answers to 4 and 5 for a second. Same setup. You have 8 to choose from. You're picking 4 in both cases. Why is this so much more than that is? And I want you to think about it. Me picking 4 poems in this situation, it's one case. I've picked the 4 poems, they go up on the bulletin board. In this case, me picking those same 4 poems isn't just one case. It's 4 factorial ways that I could rearrange those 4 poems to go in different orders on the wall. You're going to get a much higher number for an 8p4 than you're going to get for an 8c4. 6 is the controversial one. Not controversial because it's like a weird topic. Controversial because I think you could go one of 2 ways. Your big question to start this one is, does order matter or not? And we're talking about songs in a playlist. So some would say, you picking any 4 of the 20 songs, doesn't matter the order in which you listen to them. Let's go with 20c4. Because the order shouldn't really matter. You're still listening to the 4 songs. You still got to hear them. I'm going to go the other route. I'm going to go in the camp of putting a 20p4 because I really love music and I really love my Spotify playlist and I feel like the order does matter. If I am going to listen to 4 songs and then run out the door, it's going to change my mood if like my last song is like a pump up, maybe like a Jay-Z or like a Rihanna or maybe, I don't know, maybe like a real crazy, I don't know, Eminem song or something versus if it's like a soft, like Sarah McLachlan song or maybe like that song from Twilight that's really sad. So I'm going to go with order mattering here. We'll go 20p4. Get that in the calculator and you're going to get a big number, 116280. Whoops. We'll say 280 ways. So 116,280 ways you can. So you're going to flip the page now. We'll look at page 5, and we'll do this next section. It's labeled practice, so we'll do it in 2 parts. In a second, can you look down at this page and try all the questions on this page from 7 to 13. Make your decision as to why order does or doesn't matter, and then write either a combination or a permutation for these. Expect a lot of combinations because this is the day we're working with combinations. So pause the video now, and then you'll turn it back on, and we'll see if we agree on some of these answers. Okay. So let's look at number 7. Your sociological study. 4 people are chosen at random from a group of 10 people. And how many ways can this be done? I don't think order matters for this one. You're still picking the same 4 people for this study. So I'm going to go into we have 10 people to pick from, and we're choosing 4 where order doesn't matter. So check your answer with mine. I got 120. Okay. In 6, I don't think order matters here either. When I see that word committee with no special positions, I'm thinking order's not going to matter as long as we split it up with 1 combination for the amount of senators and 1 combination for the amount of representatives. So think of how many you're picking. Out of the 5 senators, you need to pick 3. And is key here, times the number of ways you could pick the representatives, and that would be 7 representatives to choose from. C4 would be a good setup for that. So try typing that into the calculator if you haven't already. You get the first one's 10, and I think the second one's 35. So you should get something like 350 for that one. Okay. Look at the next one. 9 says, I know in basketball, order might matter if you're talking about positions on the team, but it says ignoring positions. Ignoring positions, you're just talking about team members. Order shouldn't really matter. How many ways can you pick 5 from a 12-man team or a 12-man or woman team? And we could say 12C5, see if you got 792. I want you to check that with your answer for that one. Okay. 23 students in a math lovers club. I need to be in that club. And how many ways can just 4 officers? Doesn't say that they're going to have different positions or roles, president, vice president, just as officers. So this will be a plain and simple 23C4. And there still should be a lot of ways to pick 4 out of 23. 8,855 ways. Okay. Then you get to a test. On a test, you have to submit answers to 6 out of 10 questions without any regard to order. And how many ways can this be done? Well, here's your key clause here. Without any regard to order gives you the green light to use a combination for this one. So any 6 out of the 10 questions, you have 10 questions to choose from, and you're picking 6 of them. That goes into the calculator, or use the formula, and you get 210. A student must answer. Now you've got 7 of the first 10 questions and 3 of the next 5. This is just like the question with senators and representatives. Make 1 for your first 10 questions. Out of 10, you have to pick 7. And we'll multiply it by out of the next 5, you have to pick 3. And we'll say this one's going to be 1,200. And for the last one on the page, we'll try to squeeze it in here. 13 players are chosen from, it doesn't matter that it's 2 teams. There's 52 total. This can still be a 52C13. Sometimes these problems have extra numbers in them that are there to bog you down. This number is huge. 6.35 times 10 to what power? To the 11th power. Okay, to be continued.